the 16th of November, which is this. Now, we're still going back to Neo4j. Now, Neo4j, I believe to be a really amazing, um, type of software. And the reason why I say that is because remember what we've been talking about, and that is that we were talking about how when you're working with a database, when you're running some kind of a query, you have to have some idea that the information that you want is actually available in a database. In other words, if I wanted to find out what everybody has for lunch in my database, if I have like a database with a table about what everyone had for lunch yesterday, then I could write a query. It says, tell me what did everybody have for lunch yesterday. But I would have to know that that relationship exists. I'd have to know that that particular piece of information exists. Or better yet, I would have to know that the actual answer to that question exists in my database. And while that's an important thing to know, you do have to have that knowledge before you go into the actual writing of your query. But this is different for this Neo4j system, though, because in Neo4j, what we're doing now is we can look at a graph, and a visual graph, a visual system, and kind of determine what kinds of relationships are in the data and how we can go after maybe exploiting some of them. How can we actually learn about some of these relationships? And so that is why Neo4j is actually a really different kind of networking database system. You can see a giant network of nodes. Each node is information that is somehow connected to other pieces of information. And based on how those networks are connected or how they're arranged, is the kind of information that you can perhaps query in your database. And so, in other words, when you sit down to your querying in your network or in your database, you don't have to have some knowledge that that everyone had lunch yesterday in order for you to query that. You can just say, I see that people had lunch. Let's see what that query is. It's like you have this idea that information is there, and then you can write some code to get more specifics. But what I'm saying is that you can actually see visually in your data that relationship exists for you to find. Anyhow, so that's Neo4j. So let's go ahead and start this up again and just kind of look around and see what we can do with this. Now I'm going to go to I have to go to my prompt and get things started. Let's see, where's my terminal? Where's this? Hold on a second. Let me just go ahead and find my terminal. I'll switch over the view in just a moment. Nothing to see just yet. Where is it? It's there. It's there. Okay, so if I switch this over, so what I'm going to do now is we have these two different files that you can write or you can use. You go to your repository directory, and so I arrange things here. It's awfully messy. I have so many repositories I have to worry about here. But lessons 26, is it 20? It's 11. That's not 11, it's 12. Where is it? 11 and there we go. It's in here. I've changed, by the way, the name of your repository for this week, 11 and 12 week, because we started talking about Mongo last week. We're talking about Neo4j last week. I'm just going to have this is your new repository. So everything is kind of getting moved around, but all the files are still there. Nothing is lost. It's okay. I'm going to go into my sandbox, and you find that there's this file here. Whoops. If I do a cat run, and then I'm using a Mac here, if I look at this file here, the reason why I'm giving you a file, and I talked about this on Friday, was because this code really has to sit on one line if you were to copy and paste it in. But if you can break it up into chunks like this if you're working on if you're using a file. So I'm not going to paste this in there. I mean, if it were on one line, I could. In fact, to put it on one line, I have to remove these pieces here, by the way, and then I could put it all on one line and then copy that in, and that should work just fine. But I'm not going to do that because I don't have the. It's just going to take too much time to edit. So what I usually do, though, is for these types of really long commands, I just put them into a file and I run the file. Now, this is a bit different, though, because when you run this file, if you run it twice, you're probably going to get an error message. And that is because it's trying to build this Docker container again when it's already running. And it's going to say, hey, slow down, I'm already running. I can't do two things. I can't have the same container running at the same, or two different containers running at the same time by the same name. And so that's why you'll get this error message. But what this thing will do, though, is we'll run this command down here also. So that will be how you can start your container up. I'm just going to go ahead and copy that. Now, you can also see that if you go back to the slides, you can see that the actual commands themselves, the command to start the Neo4j inside the files is listed right here. And so you don't necessarily need to go back to those files each time you run this. Rather, what these files do is they just build the container for you if you don't have that file, or if you don't have the container built just yet. And so that's really where that's all coming from. I think we just go ahead and let's just try it now and see. I think that I'm running. I think that I'm already running this on my end. But if I just type in sudo docker start test neo4j, and I type in my crazy password here, it should give me something. There we are. Now, one thing I'm going to show you though is that if I just type in docker ps, you can see that I'm still running. Or I'm running this. This is my container that I'm running now. This is I'm running the test neo4j container. It's all in there. This should all actually be on one line. In fact, if I spread this thing out and made this thing bigger, maybe I can show you. You can see this on the screen. You can see it's all on one line here. Of course, if I do it like this, I can't see it myself, so I have to shrink it down a bit. But that is actually one line of code here. But the thing is, though, that make a note of this container ID, because when you want to close down this container, you will have to use this number here. So that's by typing in this docker ps command. Now, don't forget, though, that going back to your slides, the next thing I have, as violent as it sounds as a title, it's actually quite useful. Killing a Docker container. So when I wanted to kill this container, when I wanted to close it, I wanted actually not to stop the container, but I wanted to actually kind of end it on my computer so that I could build a new container. And I would do this if I'm getting an error, or for instance, if I wanted to rebuild my software, download some updates or something, I would have to do that. So how would you actually close and stop this container, or stop it and then close the container? You'd have to first of all stop the iteration, or the container Neo4j, to stop that container there, that iteration, or instantiation, I guess I should call it. But you close that down, and then once that's closed, and that means the container is running, but there's nothing in it, and so it's just sitting there in memory. Now what you need to do is you have to remove that container so that you can rebuild it if you want to rebuild it, or if you're getting some kind of an error message. Now, remember that I typed in this command up here, docker ps, before I closed it. I found out that there's this number here. In fact, that number is this number that I just pointed out right here. This one right there. The numbers are going to be different, by the way. They're always going to be different, but that's just the way that they are. But then I would go back to, I type in this command here I type docker rm followed by that number, and then that means that it destroys the container. In other words, it goes into the computer and it removes the reference to that container, so the container is gone. So now you can rebuild it, and so you can go back to these same commands here and start all over again. So that's really why these two slides are here. I think we've seen these same slides for MongoDB. It's exactly the same thing. You can try them for both of those systems. It's exactly the same. Anyhow, so going back to my container, I see that I'm running my container right here. And so what I'm going to do now is I'm going to actually go in and begin my container. So I'll just copy this because I'm lazy. Oops, not that part. Well, can I copy this? I can't copy this. Goodness gracious. Okay, well, it's 7474. So what you need to do is you go to a new thing here, and you type in local hosts, not 8787, but 7474. You press enter, and ta-da, you're up. That's the first time in class I've ever said ta-da. Cool. First for everything. So anyway, this is your login screen. Now, if you don't have a password in just yet, before you panic, don't panic, never panic. Let me just show you, going back to the slides. Oops, not this one. There we go. If you go back to these slides, I guess by default they set the user and password to Neo4j as the user, and the password is test. Now you could change those if you wanted to, but I would advise against doing that, because then it just means that you're going to have to remove the container, the Neo4j, and then some of the data too if you forget your password. And since this data isn't highly Um, I mean, it's not secure data here. It's not confidential data. It's just regular stuff. And so, just for the point of learning how this thing works. However, when you're working with a database in real for real data, where you're not just learning about it, but you're actually working with real data, at that time, I would strongly recommend that you change the password. But for this lesson here, don't worry about changing the password just yet, although you can do it if you want. I'm not going to stop you. But I would say, though, perhaps just leave it the way it is so that you can get inside there and enjoy learning about this. However, I think that I can connect. There we are. It's still connecting. It's taking its time. That's because I have all this stuff open on my machine. Hopefully it does log in. If it doesn't log in, I don't know whether I'm going to... There we go. It does take some time, and that's because if you're running a whole bunch of stuff, then you have to... I think it has to do something with your memory and allocate some things around. But you do have some, and you can look at the, for instance, the options that you have on the side here. Hopefully you can see that. These are ways you can kind of like see what's, this is all, in fact, this is the database that we loaded before, which is still sitting in memory. I'll show you how to get rid of that database and start a new one today. But the thing is that once you've opened a database, Neo4j likes to hold on to it until it doesn't, it's in memory here. You can always change them around here, but I'm just going to erase the memory, erase the database from memory and then move on to the next thing. What else do we have here? It's just there's some good online help. This question mark here, if you're having some trouble, or if you're trying to do something more than, if you're trying to do something more than you know what to do, if you're trying to find some way of getting something done, in other words, please do look at this this online help and resources, because you do have actually quite a good variety of things to read and very informative documents that might help you to kind of get something done if you're trying to get something finished. Let's see what else we have. I'm just looking through these things here. Browser sync. I think that if this is if you're working with if you're trying to, well, here you remove your data, if you're trying to remove your cache or something, if you're trying to get rid of things, but also you have this sign in button here, and I think that this sign in, all this stuff over here, is that if you create an account on the Neo4j server, then you would use this menu option to use Neo4j as a service. Here's some more settings you can work with here. I think you just play around with these things and see what they do for you. I think these are all basically views, graph visualizations, how many things to show on the screen at the same time. It's all depending on the size of the screen that you're working with, I suppose. And also down here at the bottom about Neo4j, hope you can see this. This is kind of like the information about it should be the version that you're working with. Yes, here we are. So you need to kind of keep an eye on this version information, because if you create a database today, this is the problem that I had, in fact, just this week. If you create a database like a year ago, and then you save that database or save the code for that database, and then you use it for a version like a newer version of Neo4j, you may find that it doesn't work. That means your code may have changed, the syntax may have changed, and I found that actually some of my syntax had changed. And so I had to go to this tab right here to find out what was the what was the Neo4 version number, to make sure that to see whether any changes had happened. And I found out actually that the code had changed slightly. Software is always changing, and so you have to kind of like, what I'm saying is, like, when you create code, you might want to remember what version you're working with so that you can see whether your code is going to work. Because when you read this help and resources page here, sometimes you'll be looking at some of the cipher, in fact, that's the language that we use. You look at some of the cipher code, and it will say, by the way, this code was deappreciated and it no longer works for, say, such and such versions of code. That's what you have to know. You have to go back and change that. Okay, so let's go back to the slides and see what I'm supposed to do now. So these, let's see, there we are. Click on the Okay, so now what we need to do is we need to destroy the nodes in the graph and then erase the graph. Now this is a kind of a blunt object that just destroys everything. But really this MatchN, I'll just tell you what this thing does in a very, very basic form. And that is MatchN is a function which grabs all the nodes in the network. It just grabs everything. So now what you need to do is that you need to detach those nodes. Now this is code that Neo4j uses. But you need to detach those nodes, which means basically grab every node, take it out of the network, and then get rid of it. And that's what you do. And when you take a node out of the network, then all the attaching, all the edges that you use to actually cement that node into the network, they all go away. And so that's how you kind of destroy your network. So I'm just going to do that right now, just to see how I can get this thing to work. If I hit this up here, I just type this at the top, and you'll see that it deleted 513 nodes, deleted 759 relationships. I feel terrible. I just deleted 759 relationships. So sorry. Actually, we can get that back. That was the note. That was the network that we were playing with from the movies. In fact, we can see that it's gone here. It's no longer there. But that was the movies database that we were working with. Now, if you want that back, supposing we're sitting back and we're showing our friends how this thing works, you can always type in, for instance, the play movie graph, and you can get that network back if you want, and you just click on these things over here. But this is all built-in data. So we're not going to do that today, though. I mean, it's still there. I'm just not going to worry about it. We're just not going to use that. So the next thing we're going to do now is I need to go back to. I'm kind of keep losing my way here. So I'm going to go back to my slides. Oh, it's gracious here. I keep clicking the wrong thing. I don't mean showing this thing, but every time I'm using my hotkeys, it just keeps showing the mess up. Good. So going back here, now what we're going to do is we're going to create our own network and our own series of nodes, and then I'll just take some time to talk about what the code is doing, and then hopefully that will be we can do some queries on our own work. Now I'll just copy and paste this code in here, but really though, in a nutshell, what we're doing is we are creating a teacher node where we have information about the name, and that's called the teacher. The teacher's going to have a jack jet. I don't know. I guess it has a jacket. That should be a jacket. Sorry, jacket, jeans, and she has a color marker in her hat. And so this is just some basic like metadata that I'm going to use about this teacher. Now, then a teacher has students, and so now what I'm going to do is I'm going to create another series of nodes here, and these nodes are going to be called student. And so for each student node that I'm creating, that's how you create a node. This is the teacher node that I'm creating, this colon teacher. And over here, I'm going to be creating student. And you're using this create command. Don't forget about that. You're using the create command. But for each student, I'm going to be creating some metadata, and that is that I'm going to be creating a backpack. The student has a backpack. This has an extra utility, which is going to be called the extra utility. And then the student's also going to have a test score, which is a random number. Anyway, I think that this code is kind of meaningless unless you actually see it see it running here. And then we'll just run it here. Oh, and by the way, I'm also creating a TA. The TA has a name, and the TA has a machine, which is called a laptop. So I'm going to go back over here. I'm going to just dump this into this space up at the top here. I push this run button, and you can see that I have created 8 labels, created 8 nodes, a set of 24 properties, and it's created in this amount of time. But the most important thing to notice, though, is that if you look at on the left-hand side where it says the node labels, all this information over here is your network now. You've actually created a network, which is called the default, which is the default network, but it's the network, nonetheless, that we have created. Now, we still can't see this network. It's still not there. We can see the code by clicking on code, and so you can get an idea about what it was that we actually typed in. Where we created a teacher node. We created, I think it was like 10, was it? No, it wasn't 10. It was several different, no, 5, sorry, we created 5 student nodes. And we created a TA node here. And so we have this information in our network, but we still can't see it. So what we're going to do now is we are going to, we're going to go back and find out how there's a command here we can use to actually show everything. So let me just go back through this code one more time. We're creating a teacher node. We create a student node, and actually we're creating, every time we create a student node, we're going to be adding some information, including a test score, and that's why this extra code is here. But we're also going to be creating a TA node, and the TA node, I mean, these are all the stuff that happens inside here is like the extra, I guess the supplemental or the metadata that you'd have. So for instance, our teacher metadata is this over here. The student metadata is going to be this stuff in here. That means basically every student has a name, they have an extra utility, and they have a test score. And then over here, they have the TA or the TA that we're creating, and the metadata for that is going to be a name, which is called TA, and a machine. Okay, so when we type in this command up here, we've seen this before, MatchN, return N, that means grab all those nodes. Let's show you up here. Grab all the nodes. And by the way, you won't see this over here. You have to click on graph right here. You can see that. There we go. You can click on this and then you get this over here. When you click on graph, don't forget you have to click on the graph. You can see that. Click on the graph. So anyway, but this is just our nodes. And so if you hold down your mouse and you drag around on the screen, you can actually move everybody around like this, which is actually kind of interesting. But when I click on, for instance, the teacher, I click on this relationships or whatever it is. I see the nodes over here. Oh no, just lost everybody. Oh no. Hang on, let me do this again. I just lost the teacher. Who does that? Goodness gracious. Hang on. It's just easier doing this. But anyway, though, but you can see that you have actually if you click on the teacher in this. I wish I could show you where I'm clicking on the upper left. There's like this teacher button. You see that? Teacher 1. If I click on that, if I look at the bottom, like where this caption is, hopefully you can see them clicking down here. You can see that caption and, oops, just lost it. There we go. You can see jeans. You can see I think that's supposed to be jacket. That's jacket. No. Jacket, it's a misspelling. But you also see like there's marker color. These are the actual pieces, like places where you can store information inside that node. And so what I'm saying is that when I type in code like this, this isn't very helpful to read. Let's go back over here. Oops. When I go back over here, what this is doing is when I'm creating my teacher node, I'm actually creating space in that node to hold on to several other pieces of information too. And you might need that information. Same thing goes for a student. I'm actually creating the student, and I'm creating a place where each node, I'm creating actually 5 different students' names here. And for each student, I'm holding on to information about the name, the extra utility that they're holding on to, which in this case is a backpack. And then this plus R business, what that is this is a string that's going from 0 to 5, where I'm just adding student 1, student 2, student 3, and this is backpack 1, backpack 2, backpack 3. And then over here, each student here has a random test score that I'm creating, and this is just some elaborate function that I put together to give me a score. It could be anything. It's just a random number score. It's nothing else. Okay, so there's that. And now let's go back and actually get to see our network that we're working with. And so we can click on, actually we'll go up to the top here. And so this is our network. Now the only thing missing from this network is that these are just a bunch of nodes which are just circling around in space without anything actually connecting them together. In other words, the database has no idea how the students and the teachers and the TA are connected to each other. There's no information in this at all. And so what we have to do is we have to add the edge information. Now, this is how this works. Again, what we have to do is we have to match, and that means, in other words, we're creating nodes here, teacher, student, and TA. We already created the names of these nodes, teacher, student, and TA. In fact, we created those names right here, teacher, student, and TA right here when we created the nodes. And now, excuse me, we have to tell the software how teacher, student, and TA are connected. And so this is kind of how the system works. What we have to do here is we have used this command here called merge, which is to essentially draw a connection between one type of node and another. And so what this is doing now is it says, grab all my teacher nodes, which I'm going to call T, just to make your code easier. I guess you can always just type in teacher, but T stands for teacher, S stands for student, and A stands for TA. So what I'm doing is I'm grabbing all the teacher nodes up here, and I'm saying that the teacher nodes has a relationship with the student nodes, which is right up here. And that is that it's a one-directional type of system here where the teachers actually instruct the students. It goes from the instruction follows from the teacher to the student, not the other way around. Teacher to the student. Now that is, and I know that direction is this way here. Teachers instruct, and you always have like this. You always have this colon in front of whatever the name of the relationship is, and the relationship is going to be inside these square brackets. So this arrow says that the teacher instructs the student. Now this arrow over here says on the other side of the student, the TA, which is up here, the TA helps, with this arrow here, that's an arrow, helps the student. If you think about it, it's like this dash and this over here, this is an arrow, and that's the tail of the arrow, and this is the stuff that belongs inside the arrow. It's the same thing here. So really what I'm doing is I'm creating an arrow, and in the middle of my arrow I have the square bracket colon helps close square bracket, and this arrow is like the relationship between the TA and the student. And again, this is going from the TA to the student. In other words, the student doesn't help the TA, but rather the TA helps the student, and we can see that because of this arrow. So we're creating a series of kind of directional relationships. Let's look at the next one here. Again, merge. That means that create this relationship where A, which is the TA, and the arrow is pointing to teacher, which is T, and the relationship here is listens to. So the TAs listen to the teacher. Wouldn't that be great? I'm just kidding. I'm just kidding. So anyway, the TAs listen to the teacher, and that is like a relationship between the TAs and the teacher. Now, the next relationship that I'm going to do here is that the teachers instruct the TAs. TAs instructs the TAs. So that means that the TAs do or carry out the instruction that the TA or the teachers have given them. And so that is the relationship between teachers and TAs. So the TAs don't instruct the teacher, but the teacher instructs the TAs. Now, on the other side of the arrow for this TA, we have, for instance, the students helps TAs. Students help TAs, TAs help students. It's the opposite over here. So for instance, over here we have students helping TAs, and here we have TAs helping students. And so it's like it's all the way around. And so we have this code that you can use to create the relationships. Now let's just go ahead and dump this into our code. And see what we can do. So if I go ahead and just paste that in there, I hit this little run arrow, and suddenly I have the relationships. They're all shown. Let's see, I've created 25 relationships, and they're all there. So now how do I actually show these things? Well, again, we have to select all the nodes, which is this MatchN, return N. That means grab everything and show me what you got. And so over here, I just type in this code right there, and you have this rather squashed together little map. It's actually kind of fun. You know, when I first saw this thing, I just couldn't stop playing with these nodes. It's just ridiculous, isn't it? Just ridiculous. Anyway, but still, this is a very good indication of like how you can kind of get a visual idea about what kinds of relationships or what kinds of queries, more importantly, you can type in. What can I do to learn about the relationship between the TA, the students, and the teacher? So for instance, if I want to find out, like, okay, well, what's the relationship between the teacher and the TA? I can see that's instruct just by running my mouse over that instruct edge. And over here, if I run my mouse over the instructs, what kind of relationship do I have with my students? I can see the teacher instructs the students, but also I can see that the TA helps the students. And so in my mind's eye, this is giving me some ideas about how I can go through and what kinds of queries I can type in, but also, though, what kinds of relationships I can explore. Another thing I want to talk about, though, is if you're thinking about, how do I find out exactly what kinds of relationships I can explore, like what are the limits on my relationships? Well, what you need to do is you could type in, so I can go back in here and just paste this in there. I just copied and pasted call db.schema visualization, press enter, and it looks like some kind of cool t-shirt design. But actually, though, this is an important thing here, because this is in some ways, I hate to use the word schema, but it's the schema. It's the relationship between how the nodes are connected to each other. In other words, every piece of the rule that we typed in, I mean everything we typed in in our code here, all of this stuff over here, these rules, have all been added into this graph. And so, for instance, you can see that the TA and the student at the very, very top here, they help each other, which is exactly what we're expecting to see. The TA, because the TA is a student, they also help themselves. And so that's where that comes from here. And the students, because they're students, they help each other or they help themselves, which is that over here. But now we can see that the teacher instructs the student, which is where this arrow comes from. And let me just take you back for a second here. The teacher instructs the student. If you go back to this code here, you can see that the teacher instructs the student, which is this part right down here. And by the way, I have the text downstairs here, so you can have a kind of you can remember what it is that each of these rules is supposed to do. But the teacher instructs the students, and you can see that this is a directional arrow, which means the arrow is pointing from the teacher to the student with this relationship. Now keep that in mind when we go back over here. The teacher there's an arrow from the teacher to the student with the relationship instructs. And so that's where that rule comes from. What about this rule here where the student helps the student? Where does that rule come from? That rule comes from students is, well, I guess what's talking about here then? The TA and the student helps the TA and the TA helps the student. That's where that rule comes from here. And so we have this helps right here and right here. So basically, if you're a TA, then something is pointing to you that says helps. If you're a student, something is pointing, or another student is pointing to you that says helps. Now, let's see. Over here, teacher, or the TA listens to the teacher. What rule is that? It's right here. The TA listens to the teacher. It's that rule here. Where if you're the student, or sorry, if you're the TA, then you listen to the teacher. However, if you're the teacher, then you instruct the TA, and so that's where these are coming from. Remember, these are just arrows, like arrows in text. And those arrows in text, when you put them in graphics, they look like this, which is actually quite exciting. It's like it really makes it easy, I would say, to understand what the relationship is, and that helps to inform about the types of queries that you can now write. Let's just go ahead and try another one here. So let's say that my first major query that I want to type in is I want to find out who instructs whom. Whom, that's exactly who is it that's instructing, who's getting instructed here. So I'm going to copy this code here. I'll take you through the actual code itself and talk to you about what it actually does. But when I type this in here, I get this graphic that comes out. Now let me just show you something though. But notice how when we type in a query, our query is answered by a graph. That's completely new. We have never seen this before. We've never seen a graph actually been as a response to a query. But that's how we have to talk to. That's how we can talk to Neo4j. But I think that also you can click on this button over here called Table, and Table gives us, you guessed it, a JSON file that we can use, that we could probably use for, we could capture, save it, and put it into Neo4j if we wanted to. But we have that information here. But also though, we have text. Here we go. Text. Here's some more information here that's more text ready. We can parse this out, put it into our a website or something else. And then we have the code itself, where we can get an idea about what the actual command is. And so what I'm saying is that you have 4 different ways that Neo4j is responding to you. You have the graph, you have a table, you have some text, and then you have the code itself that it's just spitting out and talking to you about what it did with the code. But really, I think that most people will use Neo4j to look at the graphs. And so here, this is kind of what we've seen before, and I think we all knew this was coming because the rules were so basic. But this was a graph that we were saying, okay, and then we're running a query here that says, tell me who was instructed, or who are the students instructing here. So you can see that, for instance, this is your. Let's close this up a bit so I have a. Oops, I want to do that here. Edit this thing here. There we go. So what we have here is we have a match. Again, that's like grab all those nodes that are, and I'll call them T. I'm going to say grab all nodes I'm going to call T. This is kind of a strange way of describing this, but I hope it works. But I'm going to say I'm going to grab nodes and I'll call them T, for which those nodes satisfy this constraint. And this constraint is that show me whatever node it is, such that it's a node and it is somehow connected to another node, and the relationship between those nodes is a student instructs, or a student is being instructed. Okay, so in other words, here's like your wild set, or your wild card, I guess. It says basically it's saying show me all the nodes which are connected in some way to students being instructed, and that's really all the nodes in our network here. And so when we have all these nodes in our network, we kind of get this kind of system here. I mean, that's what we've already been seeing. But really, though, I think you get the idea that what it's doing is it's just saying, okay, write a query that centers around the students to show how they're being instructed. And so we get this network here. So the students are being instructed by the teacher, and the teacher is instructing the TAs, which are also students. And so that's really what this is saying here. It's like you're saying, show me all these nodes for which this relationship is true. Let's go to another one and see whether we can get another more interesting graph out of this. This is another type of graph where what I'm doing is I'm saying, give me, I'll just run this for this graph here. Oops. Over here. But again, give me all the nodes for which students are being helped, that have something to do with students being helped. And so how can I go back here? Can I erase that? Yes, I can. Okay, so give me the all the nodes. So this says here match T, and what I'm saying is give me all nodes, call them T, whatever these nodes may be, call them T, and this is the relationship I'm actually interested in looking at. So you can see how there's a node here which is empty. That means a wild set. Give me any node here which is somehow connected to this relationship of S being helped by some other node. Whatever that relationship is, showed on the screen. And here you can see that students help themselves, but also students are being helped by TAs. And this actually is the relationship that we see. The relationship actually between teachers and students is teachers will instruct the students, but that relationship isn't that teachers help the students, it's that they instruct them. The actual TAs and the students themselves are helping each other. And so really this query that we're typing in here is really exploring this relationship where we're talking about help. Where does the relationship help actually come in? Not instructs, not listens to, but help. And so the query is going to return something where the TAs are helping themselves, and they're helping the students are helping themselves, and they're helping the TAs. And so that's what this relationship is here. The TAs are helping themselves. I mean, they're helping the students. Students help TLs, students, or TLs help students. It's like that's kind of how it is, or that's just your relationship. Yeah. Okay, let's try another one here. How about who listens to whom? So this is the next big piece of code we're going to type in. Again, create this network in memory. Call it. You're going to grab all these different nodes. Call that T. And the relationship that I'm interested in looking at is this piece right here, where, for instance, any node, which is where a student is being listened to by another node, is something I want to see about. That's really what this is saying. Any node, that's what this is. Any node which is connected to a student being listened to another node is this network that I want to show. And so I'll just copy that, go back here. I have to get rid of this. And I'll just paste that in there. Boom. Oops. There we go. So what do we get here? So the teacher and the TAs are being listened to and they're instructing. Teachers are instructing TAs and the TAs are listening to the teacher. Now, one thing I will say is, why do we have so many different nodes which concern this teacher instructing TAs? Well, that is because we have, what was it, 6 students here, and so we'd expect to find 6 instructs here. Remember what this relationship is that show me all the relationships in which the students are being instructed, or if there's some student node involved in being instructed. And so this is where everything is. A student is being involved in each one of these relationships because the TL could be a student, or maybe there's a TL that's working with a student. But what I'm saying though is that I know that these graphs are not maybe as readily available. The knowledge you get out of these things is not perhaps as readily available as you would expect to find when you're running like an SQL. But you do get you do get some you get some knowledge here out of these graphs, and then it takes some time. At least in my case, it took me some time to kind of stop and look at these graphs and kind of determine for myself what was actually being said to me, like what was I actually learning from my data about these graphs. And so I'm hoping that if you spend some time like just typing in some of these commands, like make a network of your own, and type in some of these search queries, you'll get used to kind of like seeing the response from the graph, and then from this you can start inferring relationships, and then maybe starting to understand your data a little bit better. But this is actually an important thing because, for instance, imagine you're trying to write a graph here to find out who knows who. You could type in a query and find out who is a direct friend of whom in this social network, and you could get a graph of all those people that are actually connected. And so it's like it does give you like knowledge that you can use in a visual sense, and maybe that's easier to read in than when you get that knowledge in text. These are some other important commands you can type in that just give you an idea about what to expect. Let's see here. I'll just type in this one down here. I think we haven't run that one here. Let's say display all nodes with their relationships, just to see what this one does. I type this in. What this is doing is this says match the node A and R with anything else, return A and R. It's not where it's basically, what that's saying is like, show me, again, show me the graph. It shows me the relationship of any node that's connected to any other node, and then show me what that graph is. This is just another way of showing you what the graph is. So show me, just grab any node and any other node. It's like a nested for here, and how they're connected is really arbitrary. But then return that relationship that you find as a graph, and that's what this is. Let's see what else do we have here. Display all nodes and their relationships. In fact, I think this is probably the most important query that you have to worry about here. Match n, return n. You'll have to use that probably all the time. But this is actually not a bad thing here. This is a call command, which isn't necessarily going to give you a graphic, but it will give you an idea about what the relationships are, or the relationship types are in your data. So you can see this is this has the relationship instructs, helps, and listens to. So in other words, you have this idea that those are the kinds of, that's the scope now of your data. There's some other things you can work with too, some node type properties, which I think are actually kind of important if you're writing queries. You may need to know, for instance, like what's the what actually is the information that what metadata is connected with each of your nodes. Here you can find out. For instance, we have the teacher, we have the load label teacher, property name, we have the property types, and we have some other things too that you can learn about these nodes. Anyway, but what I wanted to do though is in the time that we're out of time now, but maybe over the during the week here, I would encourage you to go through and click on some of these, or go to this website here, the Neo4j graph gists. I'm not exactly sure what that word really means, but you have some really interesting types of graphs that you can play with. It's like the tutorials, where you can go through and kind of learn more about how you can use Neo4j for your own work. And so, for instance, if you click on like data analytics, for instance, or data analysis, you have some interesting tutorials you can follow where they give you the data and they give you some other things, and they kind of take you through how you can use these data or this database more effectively to learn more about your actual information. It's the relationships of the information. So you can just like click on, for instance, here, this is graph databases, links, I don't know what these are. Oh, here we are, modeling the Tour de France, the old bike race. You can click on these things here, and then it will take you through all this, some data you can type in, and then you can run some interesting queries and kind of analyze the Tour de France. So they're fun, and I'd recommend that you just spend some time going through these things here, because if you're going to be creating your own graph, you might use one of these types of systems to model your own analysis or your own graph or something. It can only help. It can only help.